Today we're going to talk about how to build an elastically scalable multi-tenant free big data service. A lot of our developers today are building services either for their own company or they're building big data services for other companies. So we thought it would be great to actually go through a real live example of the service that we personally had to build and go through all the technical aspects of it. This, by the way, everybody, the webinar is going to be on YouTube, so we have the YouTube channel. My name is Alan Ho. I am the product manager for Apigee Insights.
Hi, I'm Rajesh Bhargav. I am part of the engineering team here.
Hi, I'm Shailendra. I also work on the Insights engineering team. And
just to let you know, we're going to be also posting these slides, also just slide share as well. So, we're going to talk a little bit about, when you're building a service, you always want to know why and what you're trying to build. We'll tell a little bit about why we built Apigee Insights for developers. We'll give a quick demo to give some context on what a big data service would look like. Then we're going to get to the real meats of things, which is the technical architecture and how we actually crafted the developer experience. So to provide a little context, we have a program at Apigee and product at Apigee called Apigee Developer. This allows our both customers and just regular developers to go try out various technologies from Apigee. And we're adding, what's new is that we're adding in the next week or so predictive analytics to our suite of products. So, first question I have is, what did we actually build? Shailendra?
We have been working with a lot of our customers and partners to work on the big data problems. And what we found is that there is no developer-friendly system or tooling that is available built around solving big data problems. We, of course, have a lot of tooling available in the open source system. There are some proprietary tools available as well, but none of them cater to a developer who is just starting on solving these big data problems. So we ended up building a cloud-based big data service that is multi-tenant, that is scalable and secure.
Mm-hmm. And the kind of problems that we're solving are building what we call context-aware apps. These are apps like Google Now, Facebook, your Facebook news feeds, Netflix recommendations. Data that's driven based on not just who the person is, but also behavior. And so Rajesh, tell me a little bit more from a data side. What's so special about behavioral data?
Yes, that's definitely the shift that you're seeing in the digital world, where the content is now being served, is very personalized, by looking at your behavior, what you have been doing in the past. You would see this very often that if you went and searched somewhere for, let's say, furniture, now the next site you browse onto, you start getting ads related to furniture. So that's an example of behavior-driven apps or websites that are out there. So we're definitely seeing this shift. It all comes from mining your behavior, recognizing you as a user, mining your behavior, and then putting that to use.
Okay. So, Shailendra, you said about developer alternatives for machine learning. Obviously, machine learning has been around for a long time.
Yep.
Just kind of tell me why we even decided to go build something that's slightly different than what they were before.
Yeah, I think traditionally you will see that there are tools like R, SAS that have been around to solve these kind of problems for a while now, but they just have a very steep learning curve. The other thing that we see happening today is that the Hadoop ecosystem has been evolving to provide a lot of tools around predictive analytics and machine learning. But these are just the tools, and they do not necessarily provide you an end-to-end view of the problem.
So it's like Spark.
It's like Spark, MLab. There are a bunch of other open source libraries that are helping you build predictive algorithms as well.
Yeah.
Recently, we have seen companies like Amazon providing machine learning as an additional service on top of their EC2 mechanism as well. The problems that we noticed with all of these tools is that they are actually tools. The developer still has to do a lot of wrangling in terms of wiring all these tools together so that they are able to solve a meaningful problem.
Yeah.
And the primary goal that we wanted to, that we had when coming up with Insights was that we wanted to provide an end-to-end development environment where that will cater to essentially all the way from capturing users' behavior, then understanding and analyzing using some kind of a descriptive analytics capabilities, and then carry on that understanding onto developing predictive solutions.
Yeah.
And all of this essentially with the end goal in mind that ultimately all these predictive outcomes have to be consumed by an application so that they can be presented to an end user.
Okay.
So we wanted to give an environment to the developers where they can do all these activities seamlessly, as well as have an accelerated development environment to complete end-to-end solution for context-aware app.
And the most important part for developers is that it has to be free for them to try it out.
Yes.
Right? So that's such another, I think it's really important because just having a really expensive tool, whether it's a deploy or things of that sort, it's not easy to do. I mean, there's so much hype and opportunity for big data, but it's just, if it just costs way too much, you don't want to do it, right? So I think the free aspect to it was actually a major constraint. But it was also a major engineering challenge for us to do it cost effectively.
Absolutely. And just to build upon the point here that Sharon mentioned, the whole experience in the world today is that we have a set of tools that you can work with. There's no end-to-end solution to, hey, I want to gather data, work with the data to create models and take this model to production. What we have tried to do is bridge that gap, provide a solution that lets you do this thing end to end and in a very easy manner.
Okay. Let's see if there's a question or two. Okay, there's no questions at the moment. And why don't I just give a little quick demo of what we actually built. By the way, anybody can go in the next week or so, you'll be able to log on to Apigee and be able to see this fourth extra tab, or predictive analytics. So we want to show you quickly that you can actually do some event. Let's say, for example, you want to figure out what type of events led to somebody actually buying some baby clothing. We can do some visualizations on this. So you can see of this 3,000 people who bought stuff, the first thing they did is visit the store, which is really important. Then we have kind of the predictive side. I'm going to show you a little bit later on some R code. But the code is actually, your predictive model is actually going to be developed in R using an R SDK, and the scores would pop up in the system. And once the scores are in the system, you can actually export the scores to other systems, such as a backend of the service or a NoSQL database, things of that sort. So that's kind of at a top level of how the product works. Let's kind of go into the actual architecture and see how that would work. So Rajesh, tell me exactly, from an architecture standpoint, how would we actually construct a system like this?
Yeah, sure. So let me first start with a very 10,000 feet level kind of a picture, and then go down into the component architecture. So if you look at the slide here, you see three building blocks there. The lowermost being our distributed processing foundation. This layer actually brings us the capability to compute in a distributed manner to scale to the big data needs, and it's built upon platforms that give us that capability. For example, S3, Hadoop, and UserGrid. On top of these platforms, we have distributed data and job management layer, which lets us browse the data on these platforms or launch jobs on these platforms. And that's the lowermost block, sort of a building block. This is followed by the computational algorithms that we have. This includes the data pipelines and all the machine learning library that we have. This is where our secret sauce resides. For example, we have graph processor here. This is the piece of code which does graph aggregations for us. The topmost layer is the user interactions, where we expose our capabilities to various user interfaces. Alan just went over the UI user interface for us. We also have, as you mentioned, the modeling workbench, which is used for creating models and is exposed through R. That's another interface that we use. And both of these are sitting on top of our public APIs. And folks can use the APIs directly to build their own interfaces around that. And here you see the view of the system level components that we have in the system. And over the course of this presentation, we'll probably talk about a few of these in any case, so I'll leave that to later.
Okay. So maybe like kind of first question I have is like, how do you even get data into the system? Like how does that work?
Yeah, so we go through the process of data ingestion. Of course, the data is the core of the system. So the way we ingest data, the way you are able to transfer data to us, there are three techniques that you can use. One is the UI provides a way for you to upload the files. When you do that, it's an interaction. You can browse around, select a file on your filer, and say upload, and that gets the file loaded into our system. The second is the batch way, where if you have, we can talk to your S3 bucket and monitor that to get the data into our system. And lastly, we have the data flowing through your APIs. If you are Apigee Edge customers, data is flowing through the APIs through our servers, and we can ingest the data through that.
Okay.
The whole process of data ingestion involves getting the data into a staging area, going through a process of cleansing that data, creating some stats around that data, and then making it available for the system for users to create all these components.
Okay. And so, can you kind of like so you're just kind of backing up? There's multiple ways to get data into the system. We need to do some level of cleaning of the data just to make sure that you can even do something on it.
Right.
Then what happens after that? Like when we get the data into the system, what actually happens?
Yeah,
There's
so
obviously other things we need to do to have that end-to-end experience.
Definitely. So ingesting data is just the first part. That's the starting block. From there on, we can now go on to configure either the journeys or the models that are to be built on top of that. Typically, what the process looks like is as follows. We ingest the data. The data can be your event-based data, which is a series of actions that a user is performing. That tells us about your behavior. Or it could be your consumer profile, which tells us about who you are. Once we have the data ingested, we go through the process of creating aggregated behavior graphs on it. These behavior graphs combine your activities with the profile and represent it as in the form of graphs.
So this is kind of interesting because this is, just like kind of the data warehouse world, you would ingest data into a staging table and then you would create cubes, SQL cubes. But instead, we're ingesting the data, like much bigger sets of data than what a traditional warehouse, and we're creating these graphs. Why graphs instead of just the traditional SQL cubes?
So if you look at the kind of data that we are dealing with, the relational databases are not powerful enough to represent the complex graphs that come out of these data.
Okay.
We had to develop our own language, our own graph processing capabilities to be able to represent the data that we want. We are dealing with events here. We are dealing with temporal sequence of events here, and clubbed together with a profile. And the graphs that we get out of these things are very complicated.
Okay.
Just to add to Sophia, we also deal with unstructured data, which has its own challenges in the RDBMS side of the world.
Yeah.
In terms of representation. So once we have the aggregated graphs, then depending on what question we are trying to answer, if it's journey, then we load these graphs onto the query server for querying from the UI. In case of model, we apply the machine learning algorithms on top of this aggregated graphs to generate models on that. And finally, we connect with the serving layer, whether it is exposing the data to the user grid so that it can be served out, whether it is delivering the data back to the customer data store so that the customer can ingest it, or whether it is serving the application layer so that the UI can work with the data.
Okay. We have a couple other questions. Like, one question was, is the process of doing all this in batch, or how do we actually create this? How do we actually string these things together?
That's where our pipelines come in handy. So when you are, if you go to the UI, if you're constructing a journey object, for example, if you're trying to construct a journey, what's happening behind the scene is that we are constructing a journey object, and part of that construction is we define a pipeline that needs to be run in order to create this journey object. That pipeline is essentially chaining a sequence of steps that need to happen for this journey to be created. And so once this journey is created, once the pipeline executes, then we load the data somewhere where it can be then queried up. The process of creating the journey, configuring the journey happens online, but the creation, the aggregations that happen, they happen as a batch.
Yeah.
And then you get notified that now your object is ready for query.
Okay. So we have this batch management system, pipeline management system that helps string together. I think
Absolutely.
actually when you actually talk about real world systems, we're talking about 20 plus MapReduce jobs strung all together to actually do a lot of these transformations.
Easy.
Yeah. By the way, please just continue asking questions during the conversation, and we may leave some of those questions towards the end, and we may answer some of them in line. But we'll try to answer as many as possible. So can you tell me? Let's talk actually about. I think everybody's really interested in multi-tenancy. So can you kind of tell me a little bit about security and multi-tenancy? How do you think about that?
Yeah, I think what we have found is that when you are working with users' activities and their profile information, a lot of times you are dealing with sensitive, personally identifiable information.
Mm-hmm.
And it was one of our design goals to make sure that the system is secure enough, it provides enough level of data isolation between different users. And we've also actually gone ahead and audited the inside cloud setup to make sure that it is HIPAA and PCI compliant. So what it means is that we are enforcing a bunch of data access processes that are secure. Even internal insights users and operations people do not get access to your data readily. They have to go through a few procedural steps to get access to that. We also encrypt the data that we store in the cloud, and even Amazon users or EC2 operational people will not have access to the data that is stored on the inside system here.
Okay.
So the main guiding principle here has been that provide an encrypted pipe or a channel to bring the data in, and once the data is inside the system, you encrypt it whenever it is being stored or moved around.
So wherever data rests, it is in an encrypted form.
Yes.
Okay, so kind of like from an end-to-end perspective, right? We would have the data. We would have the data in, let's say a recommendation scenario. You would actually want to query a recommendation,
Mm-hmm.
and this is on your website, right? The request would come into this real-time service, which is actually built using a combination of Node and a backend as a service, which underneath the hood is NoSQL. All our heavy lifting machine learning is happening in this backend in the Hadoop cluster that's pulling data from this persistent store and then generating those results and then storing it into SQL. Is that kind of the end-to-end flow?
Right. Yes.
Okay. Cool. The next thing is like how do we end up making the service free? Because we want to tell me something about the scalability aspects of things. How do we make it scale, and how do we actually make it cost efficient?
There is an aspect of multi-tenancy that also plays in here. For our cloud offering, it's very necessary for us to be multi-tenant.
Mm-hmm.
to be multi-tenant because it gives a lot of operational efficiency, right? And as part of that, as part of multi-tenancy, we have to deal with a few things. One is the data side of things. The other is the actual system resources. So scalability is one aspect of when we are considering the system resources. It's not just being scalable around data for a single person. It's also a single customer. It's also important to make sure that in a multi-tenant environment, not one person is hogging all the resources.
Okay.
Right?
How do we do that? Because
yes.
Just a background on Apigee developer. We try to we let people use the product. Developers use it for free. We do have some limits on how much data they can upload, but we want to make sure that there's times that you might have, especially when there's an event, we might have lots and lots of developers who are using the product. We still want to give them the access to it. But the truth of the matter is that only a small fraction of those users actually continually use the product on a regular basis.
Right.
So tell me a little bit more about what went into our thinking when we were trying to create the service so that it was cost effective to deal with this kind of elastic demand.
Okay, so yeah, it boils down to two things: the choice of platforms that we use and the techniques that we use on those platforms. The choice of platforms we already talked about. The technique in terms of techniques, we use what is called as ephemeral and elastic scaling, which is very relevant for EC2 platforms or Amazon platforms. We use horizontal scaling, which is a well-known technique as far as scaling your app servers or database clusters is concerned. And then sharding, another very common technique used, where we instead of just dealing with, let's say, one cluster or one database, we shard the data itself into multiple parts, and such that at any given point of time you can go to one partition or one shard and then get the data from there. So these are the three most important techniques that we use. We have the slide here represents which part of our architecture, what components of our architecture use which technique in order to scale. For example, on the staging area, we use sharding, such that you can set up one S3 bucket, for example, for each account that you're trying to onboard. For the ephemeral Hadoop cluster, by the way, our clusters, ephemeral as in they can be shut down or brought up on demand. If there is no job running, we actually shut down the server. If there is if you get a job that needs to be done on the cluster, we bring up the server. It also scales up as more and more jobs come in. We actually scale up the cluster to a certain limit, and then if again there is no jobs, then we shut down the server. So that's how our cluster scales. We can also do sharding on clusters, where we onboard certain accounts on certain clusters based on their requirements.
Yeah, so for example, if we have a paid customer who has very, very tight SLAs, we want to totally block them out from having to, even though we have an elastically scalable cluster, we want to put those people on their own clusters so that they can they have a dedicated resource for their resource. Okay.
Processing needs.
Cool. So that's like we just have multiple techniques to actually get scaling. Okay, let's take a look at some other of these questions too. The question was quality of service, which we just answered. So for Apigee Free, the way that we were going to do for Apigee Developer is that this is really an environment for people to do mostly learning and their experiments. The way we're going to do it is basically we're going to look on a regular basis how many jobs there are running concurrently. We'll scale up and scale down as necessary. The cool thing I think about our system is that there is kind of there is a trade-off of moving data from separating out the compute and the storage requires you to move data in and out of the system. But I think the way that we've done it on Amazon, we balance that out because you can actually pull data in parallel from S3 and push data back. So we made a lot of trade-offs in terms of cost versus speed and performance. but given how nature of Hadoop and how it can process data, pull data in parallel, I think we made some pretty cool, interesting choices around that.
And absolutely. And just to be clear, whether the cluster is ephemeral or it's a static cluster is completely configurable. So, for example, for an on-prem scenario, if we are sharing your cluster, it doesn't have to be ephemeral.
Okay. So let's talk a little bit about the UI stack. So we just maybe I'll just go back into the UI a little bit later. Tell me a little bit about how do we actually build the UI and the APIs.
So UI is probably one of the clients that is available to you to interact with this platform, right? And that's the primary goal of using the Insights UI. We also have built some analytics capabilities in the UI so that you can analyze the user behavior as well. Mm-hmm. The UI runs in your browser as an HTML5 single page application, mm-hmm. and it is interacting with the backend platform using RESTful APIs. These are the APIs that are public APIs. If somebody needs to interact with the platform directly and script their way through it, they can do that as well. And essentially the API infrastructure is running on a horizontally scalable cluster of application servers, mm-hmm. and supporting the requirements of the browser-based clients or any other client, or for that matter, even the R API libraries that we have, they interact with the platform using these web APIs as well.
Okay, so let's kind of quickly like take a look at what that would actually look like. So I'm going to bring up some of our developer tools. Let's take a look at the network. So I'm going to do a.
So the example that you are showcasing here, the UI is interacting with the backend application server using these APIs, right? And the web APIs in turn are interacting with our aggregated user behavior stored on Hadoop.
Yeah.
Right. And this is the data that is being queried in real time and presented to the UI using standard RESTful conventions, and then UI does a job of converting that into a visual experience that helps you analyze the user behavior here.
Okay, cool. Yeah, so we see here these are making API calls using and you can see it says start node. So it's kind of using a graph-like query language,
right.
Not SQL. And then it's returning the data using basically
in a standard JSON format.
Standard JSON format. Okay, very, very cool. And I think this is kind of applicable for any kind of. What we've seen is that it's becoming more applicable for any kind of service that we want to. That people would, if you're trying to build a UI or build some analytical services, kind of traditional way is, okay, I'm just going to give you an ODBC connection, some raw database connection.
Right.
But I think that now, especially if you want to build apps, you need to have APIs, you need to make it very scalable to interact with.
Right.
So tell us a little bit more about R, because this is kind of like, and so what I'm showing you here is a example code of building a model end to end. Right. Tell us a little bit about the process of us coming up with an SDK for building the models.
So I think the R development environment complements the Insights capabilities pretty well. R has been used for statistical analysis, data transformations, doing data aggregations, and understanding what lies in your data. And these are the capabilities that essentially you carry forward to Insights when working with Insights, right? And that's the reason choice of R was sort of a natural process of evolution for us. We thought the developers probably will not have a steeper learning curve to understand the concepts of R because it's a very simple scripting language. And we have tried to follow the similar conventions that a typical R library package follows when integrating with Insights platform at the back end.
Okay. And when we're talking about building these APIs and SDKs, tell me about the process of how do we actually come up with this n number of lines of code. Like, tell me about. I know we did some user studies. Tell me about those user studies.
Yeah, I think this has been a learning experience for us as well. We started with our very first version of these APIs as well as UIs. We went through a bunch of user studies with the internal Apigee developers as well as some of the partners that we are working with, and it just bombed. People came back with the feedback that this thing is very complicated. We have no way what's happening inside the system. The terminology is not clear, and you're not helping us to get through this problem at all. We went back to the drawing board. Worked with a bunch of people inside here at Apigee. Went through the iterative process of simplifying UI, simplifying the API signatures. And just to give you an example, in the very first version of our SDK, it would take close to about 40 plus API calls for a user to configure a relatively simple modeling problem. And after a few iterations, we were able to make it clearer. We were able to make it simpler, and we brought it down to the magnitude of like 10 to 15 lines. And essentially, we've tried to simplify the terminology involved here. That's the other feedback that we have gotten about the UI interactions as well. Is that hey, these machine learning concepts are relatively hard to understand.
Yeah.
We have taken some cues from that, and you will see a lot of places in the UI where we'll try to provide you in-context help. There are some tool tips there that explain you the terminology. They try to give you more information in terms of what's happening in the background.
I think one of the cool things about, this is really a advice to anybody who's building any kind of analytical system at all, is how you actually conduct your user studies. So the way that our approach towards developer experience is, you give a task for somebody to do, and you give them a fixed time frame, and you find out how many people are actually able to do it. So that's your success rate,
right.
And how much do they actually get through. So that's the ease of use.
So Alan, in this exercise, how was the progression on that?
Yeah, you're asking the product guy. Literally, honestly, from the beginning, we gave them an hour to 2 hours. People would get through at most 10% of it, and they failed almost 90% of the time. And towards the end, we were getting around 70 to 80% completion rates within an hour. So I think that's a great, for a developer product, that's really, really high quality. And I think that's kind of especially if you're building a service, you really want to focus on those kinds of metrics. So what about and it's not just about the user studies, tell me a little bit more about resources and things of that sort that we provide for developers. How do we go about it?
Once you sign up and activate your account on apigee.com, right? We already have some sample data loaded in there for you. A typical developer can run through a recommendation tutorial, that takes them all the way from configuring journeys, configuring models, scores, and reports, and also explains them how they can query these generated scores using Node.js based APIs, integrate with the backend as a service example that we have provided. So we hope that it's going to give developers an end-to-end feel for what steps are involved in solving a typical predictive application problem.
Yeah.
We have also tried to do some blog posts around it. We are generating a lot more sample data sets that people can work with. There is embedded documentation in the UI. If you are using our libraries, there is a wealth of API documentation included for the R development environment as well.
And I think this is kind of another innovation that we did for this release of this free developer product, which was we kind of preloaded the data ahead of time.
Yeah.
And the difference between let's say this kind of a predictive analytics product versus an application server product is that just getting the data, it takes a long time to do too.
Yeah.
So by the moment that you actually log in, you already have one or two sample data sets to use, maybe have some pre-generated models, pre-generated reports. It lets the developer kind of click through very quickly and get a sense of it without them having to go through the whole process of getting their own data sets and uploading it themselves and things of that sort, which is really important if we want to develop, if we want to get the developer through any kind of experience at all. So I think this is kind of a very cool innovation that we did.
And having those out-of-box objects available gives you a reference on how to proceed with, let's say, creating a model and creating a score and so on.
Okay. Actually we have a question from Nirmal. Can I export the custom predictive models to BAS? And the answer is yes. Again, this is around tooling. Like right from the UI, we allow you, where the scores UI, you can actually just click export and it goes into back into the service, which allows you to do your, integrate it with the push notifications or create a recommendation widget on top of it very easily. We have actually, for people who want to try it out, we do have a accounts-beta apigee.com. This is going to go to our, this is a kind of a beta link right now, but the actual product is going to go to production very, very soon. Let's just kind of summarize it, like based on what we just said. You have to take a practical approach towards multi-tenancy. I think we took, we made a number of performance decisions, as well as technology choices for it. Our costs dramatically can be reduced via elastic scaling and multi-tenancy. Developer experience, continual refinement. That's the only way to go. And we'd asked everybody to try the service out and be able to see how you can build some similar type of service too.
And send us the feedback.
And send feedback, correct. Okay. So we actually have some time for questions now. So, I'm gonna go through some of the questions we didn't answer. But as you guys, as you have other questions, please enter them in, and we'll talk about it. So one of the questions from Alan Williams was, how is this different than leveraging EMR and AWS? And I'll go to you, Rajesh. How is this different?
So whether it's EMR or your own Hadoop cluster, the one thing that we talked about is that all these the solutions out there, they give you the tools, they give you the means to execute that. By the way, we are using Amazon CMR for our needs too, but they do not give you the end-to-end solution. It's your brain. It's your manual efforts to stitch things together. Things are happening in silo, where somebody is working on getting the data in. A data scientist is then trying to make some meaning out of that data. He produces the model, and somebody else now takes this and puts to production. It's that whole value that we create. That's a big plus for what we do, what value we add to this whole ecosystem. The other part is the algorithms themselves. So EMR, that's just the means to run, right? But what is the algorithm that you're running? What's the secret sauce that lets you generate that model? That's the other differentiating factor that where we provide value.
Okay. And just also know, like, if you really want to build like these predictive models, we're talking about stringing together 20 odd MapReduce jobs all together, right? It's non-trivial. I mean, it's great. We were inspired from EMR. In fact, EMR was developed. It also pulls data from S3, etc. In fact, we can leverage elastic MapReduce to run a lot of our infrastructure. But all that, stringing together multiple Hadoop jobs, which Hadoop jobs to actually string together, all that data pipelining, that's really, really complex stuff that, in our experience, developers just don't have time for that. They just don't have time to mess around with that kind of stuff. So that's another reason why we did that.
The second thing that we've also noticed is that all the stringing and coding that you do, that tends to be problem specific or domain specific, right? And which means that if you are moving from one predictive problem to another, you will pretty much end up repeating most of the tasks that you had to do for solving the first one. and sort of that was one of our goal, was that we have a general purpose framework built that will help you, capitalize on all the abstractions and developer-friendly interfaces that we have tried to do.
Okay, cool. So we have another question.
Ninja Chris.
Are the components, those tapped into the company's AWS account or those on the Apigee side?
So I'll talk about the cloud offering here. So the cluster that we are talking about in the persistent store, we are talking about, those are Apigee's clusters and buckets that we are talking about. Now, the data ingestion can actually go to your S3 bucket and pick data from there. So that's the only place where we would be talking to your AWS account.
Okay. So all you would need to do is, you have your data on, if you already have your data in an S3 account, you just go to the identity access manager, I guess, generate credential for Apigee,
right,
so that we can just pull the data in, right?
Yes.
Okay, very cool. We have another question, which is, do you support PMML? The answer is no, and I'll the history of PMML. I think this is where, it's always great to support standards, but I've personally seen that standards just go out of it actually is a poor developer experience, because if you try to actually get a developer to write a whole bunch of PMML code, that would drive them nuts. Rather than if you give them code, like you give them 14 lines, if they only have to do 14 lines of R code, that's a lot easier than building an entire PMML model in whatever markup language that they did. So we're really trying to balance it out for a really high quality developer experience. Okay, so we have some other questions, which is, can I get insights associated to my free account? I'm running out of emails. And the answer is yes. Go to the accounts-beta.apigee.com, and you should be able to see it. I'm just giving this URL again. You should be able to see the predict box. You click it. It can take up to about 10 minutes per provision. But once it's there, you'll have all the sample data there, and you can start using it right away.
So you can use your existing account and log in there.
Correct. We answered the quality of service question. Okay. How metadata is collected or related with, I guess, existing data objects?
Existing data objects. By data objects, I think you're referring to on the UI. You're seeing all the data that got ingested, and you're talking about metadata about that. I'm guessing that's the case. During the process of ingestion, or if we are generating new data, we generate metadata around that. That's what you see on the UI postcard. So as part of our ingestion process, or as part of generating new data, that's when the metadata gets generated.
Okay, cool. We also had a question around the graph database. So tell us a little bit about graph databases, and
yes,
especially graph databases on Hadoop.
So what we use is very proprietary to us, and that because the kind of representations that we wanted weren't very well supported in other graph databases out there. In essence, we are trying to club together not just your events, also the sequence of events along with what time they happened, and the distance between nodes, and then your profile along with that, and then and build a query language on top of this, which can scale up for the big data challenges out there. So we ended up creating our own graph database and a query language to support our needs.
Mm-hmm. Okay. And just to talk a little bit more about from a graph database perspective, there are lots of graph databases out there that were geared towards more operational data stores. So this is like, for example, TitanDB, Neo4j, those kinds of databases. And in fact, underneath the hood, UserGrid is also a graph database built on top of Cassandra as well. But these are great for operational kind of real-time operations. Right. And they're great for what I call relational graphs. So this is like if you relate one user to another. But the kind of graphs that Insights builds is behavioral graphs. So these are event data graphs. So we're talking about orders of magnitude more data. And we're also talking about running really complicated machine learning algorithms on top of it, on top of event data. So the kind of graphs that you're building in Hadoop is drastically different than the kind of graphs we would build in the Neo4j. And likewise, you would need to kind of figure out what is the right, you need to have a special set of data structures for it. Oh, how do we reach the free service to try it out? Just go to accounts. I'm just going to go bring up the website again. Go to accounts-beta.apigee.com. You can use your existing free account and just log in and try it out. Are there delays in API calls passing data similar to other Apigee products? We've seen 100 millisecond delays, 100, 200 millisecond delays for API proxies. So obviously we try to minimize the amount of delay as possible. But one of the ways that you kind of minimize the amount of delay for a lot of the queries is that you pre-generate some of the results. And can you talk a little bit about kind of like some of the, especially for, when doing the patch visualization, can you talk a little bit about our caching strategy?
Right. So of course the query language and the graph database, the query language on top, it's built for scale. It's built to be able to query large amounts of data, but it would be we built a query layer, a caching layer on top of this, which is currently Couchbase powered, which caches a number of results and sub-results so that the entire experience then becomes much more efficient.
Okay. Once I build a predictive model, how do I export my scores? So I can quickly show you do a demo. So under the Predict tab, after you build your models and you do your scoring, you have this export to API BAS feature. You would basically name the collection. You would name you would put in the BAS URL, the name, your client ID and secret, and it will export it. The kind of cool thing about exporting to backend as a service, the reason why we chose a backend as a service versus a relational database is that you're always changing what you're trying to predict, right? And what traditionally happens is you end up having to create new like if you're using a relational database, having to create new tables and do indexing and all that kind of stuff. But backend as a service take care of all that stuff because underneath the hood it's NoSQL. It takes care of the indexing for you, and we've done a bunch of tests to make sure that you can scale to the millions of recommendations and still get a decent performance coming back. Do you provide any tools for data cleansing?
Right now, the data cleansing that we do is standard out of box that we do. We don't have any configurable tools yet that we provide for data cleansing. The current idea is that you would go through some kind of cleansing outside if that is needed, and then upload the data.
Okay. And actually, this was a design decision that we did a long time ago.
Yeah.
And the reason why is because even within Apigee, we have a data science team, and they all use different tools. Some people like doing their data cleansing in R, others like Python. We have a whole bunch of diehard Perl guys. Everybody has their own favorite data cleansing tool. Hive is actually used by a lot of developers to do data cleansing and data merging. So what's more important is that you give people the ability to use the open source tools that they like and provide APIs to get the data in. So the way you would do it, let's say in the case where you're doing batch data cleansing, and you want to use Apigee Freeze tool, Apigee Developer, you would do your data cleansing using Hive or MapReduce, or whatever tool you have the data be put into the S3 bucket, and then we can ingest the data from the S3 bucket.
Right. Just to complete the thought, we started going that route, and then we said that there are just too many different things that people do in terms of tools and in terms of what they need to do for cleansing. And we said, okay, for now, that's the design decision to be made, that let's keep that outside of
yeah.
the offer.
All right, so we're going to wrap up here. Thank you, Shailendra. Thank you, Rajesh. I hope people kind of got a sense of how we built insights for Apigee Developer, and that would inspire you to build your own big data services for your customers or your teams. Thank you very much.